So in this video, let's discuss how we can handle the database or how we can scale the database in a single server setup when the number of users increases. Suppose we are having a single setup server and one and at a time if all number of the users using the website increases, then we need to store all the data related to the users who are using the website. So to do that, we need to scale the database. But if we need to scale the database, we also need to scale the server. Like in the server, we have all the components, but if we are scaling all the components which are not required, it's unnecessary, right? So for that purpose, we will be having a separate server for the database. So now we can scale the database like how many users are coming according to the users. Suppose if there are 1,000 users, then we can scale the database according to 1,000 users. Or if we are having 20 million users, we can scale the database according to that to those many users, independent of this web server. So how we here we will see how the request is handled when we are having a separate database server. So firstly, we will be having a web browser or a mobile application which the user will be accessing. So user may come through mobile application or from the web browser. So he opens our website, then uh, the website is sent to, then the request is sent to the DNS to get the IP address of the website. We will be getting the IP address of the server. Then the request is sent to the IP address of the server. Here we will be handling the request. Suppose we need to do any data processing, like we need to update the data, then the right request is sent to the database where we will be updating the database and then sending the updated data to the server and then again processing the request and then sending back the JSON response. So this is how we are handling the request in the where we will be having a separate database. So now we discussed we need to have a separate database. So we are discussing the database, but how we are going to store the data? So we have two kinds of databases like relational databases and non-relational databases. So here they have given the examples of both relational databases and non-relational databases like MySQL, PostgreSQL, Cassandra, and Amazon DynamoDB. So what is meant by relational databases? So in relational databases means that we can store the data in the form of tables. And also like if we are having two different tables, we can join them. We can also join them to represent aggregated objects. And we are having four kinds of NoSQL databases like key value stores, graph stores, column stores, and document stores. And we cannot perform join operations on NoSQL databases. So it's told that relational we will be using mostly relational databases, but if it's not suitable, we can go for exploring NoSQL databases. So when NoSQL databases might be a better option. It's like when we want to retrieve the data fastly, that's when it's a good option. And also when we are having so much amount of data, like 20 millions of data, like it's too less, I guess. But when we are having so much of data, then we can use relation NoSQL. And also like when we are having a data that we cannot represent in the form of tables, then we can use NoSQL databases. So we discussed that we need to scale the database, but how we can scale the database, like increasing the database memory or like buying some more databases. So it's like vertical scaling or horizontal scaling. Vertical scaling is like suppose you are having a one floor apartment, then building four other floors on that one floor is known as vertical scaling. It's like adding more power to your resources. And horizontal scaling is like if you're having one house in India, it's like buying other houses in United States, England, something like that, like buying more houses instead of building on one house. It's like adding more resource servers to your pool of resources. Vertical scaling is good. Like building five-floor apartment is good, but it does have a limit, right? We cannot build 1,000 floors or like 1 lakh floors on just 1 lakh floors of apartment, right? It's not possible. So that's the disadvantage. And also, like if the apartment collapses, then all your home is lost. You're homeless. That's what, like, if the server goes down, then we cannot access your website. That's the problem of vertical scaling. So we have discussed horizontal scaling, like it's like adding more servers. So if a request comes, now then how will the request know to which server does it needs to go? For that, we'll be having a load balancer. Load balancer routes the request such that evenly the traffic is distributed. It acts like a traffic police who controls the traffic jam. Suppose user access the application, then we'll be getting the IP address. So here if you see in the DNS, the URL is mapped to the IP address of the load balancer and not the server. So the request is sent to the IP address of the load balancer. Here the load balancer will be routing the request to the appropriate servers. The IP addresses of the servers are only accessible to the load balancer and not to the DNS users because they are private. So this is how the load balancer distributes the traffic, like distributes the request to different servers.